right in here in this bag is the sun. The sun is very, very large. It takes up 99% of all mass in our solar system. It is also the biggest object in our solar system. Now, it wasn't always so big. It used to look like this. This was a protostar. It was a smaller version of our sun, and it emitted less heat and light, and it was surrounded by a large disk of dust. Right here on the sun are these things called sunspots. They are cooler, darker areas of the sun where the magnetic fields intersect with the chromosphere. The chromosphere is the visible surface of the sun. Out here is the corona. It's the outermost layer of the sun, and it is very hot compared to the chromosphere. However, it is not visible. It's only visible during a solar eclipse or if we use special technology. If we move to the inside, there is the core in the very center. It is the hottest and most dense layer of the sun, where it fuses its hydrogen atoms to create a lot of energy. This energy then goes outward into the radiative zone. The radiative zone is called the radiative zone because it radiates the energy out into this yellow area known as the convection zone. The convection zone uses convection currents of warmer and cooler air to bring its energy outward. Then, that energy comes out to our Earth. It travels in streams of energy known as the solar wind. And right here, this white spot is Antarctica, our South Pole. Streaming out are two sort of semicircles or ellipses coming out of the Earth's poles. These are the magnetic fields. When the solar wind from the sun travels to our magnetic fields and then the particles interact with the magnetic fields in the solar winds, they create what we know as the aurora borealis, or the northern lights. If we didn't have the magnetic fields in our atmosphere to protect us from the solar wind, all of our technology and several other things could be damaged and a lot of us would be dead, if not all of us. Thank you.
This is the third major stage of the sun. This is called a red giant. A red giant happens when the sun uses most of its hydrogen. It will slowly expand due to the lack of fuel. As the sun slowly collapses into itself, it will create a planetary nebula like this. After the planetary nebula has finished, all that will be left is the sun's core, which is a white dwarf. A white dwarf will take trillions of years to cool down into an unnoticeable black dwarf. And people think that white dwarfs are white because it's in their name, but they're actually blue tinted because of the heat from the sun.